So we're going to take a look at example number 2, which also deals with normal distribution, deals with looking at manufacturing process of a chocolate bar. So when producing a certain chocolate bar, they've determined that the mean was going to be 23 grams with a standard deviation of 1.5 grams. So this is important that we understand that this is where these values are coming from. This is going to be our mu. We'll make sure to put that in there. And this is going to be our sigma. And so we're going to quickly put that in there. There we go. There's our sigma. So we have our mu and we have our sigma. And as long as we have those two things, we can come up with our normal distribution for the graph. Now, mu I already kind of have listed, I've put in here already. But what we're going to do is we're going to just write in the numbers. So right at the mean, we have 23 grams. That's our mu, that's our mean. Now, every step up, we have to add 1.5. So that means that this one here is going to be 24.5 grams. This one right here is going to be 26 grams. Right, and right here we're going to have 27.5 grams. So that is where those kind of set in. That's those benchmarks, so to speak, and we can understand how many are going to be in between each one. Now I've already kind of put together this graph a little bit more than just a regular one. I've put all my percentages in there to make it a little bit quicker. 20 grams. And this one here is going to be 18.5 grams. All right. So this is actually very common in what we might see as being a manufacturing process. We don't all have the exact same stuff. We have some that are bigger, some that are smaller, and that's going to affect which ones are going to be sent to market. Companies aren't going to want to send really, really small ones to market because, well, that's not good for business, and they're probably not going to want to send like really big ones to market either, because then people feel like they're getting gypped other times. So they want to send the ones that are kind of in between a certain value. We can figure out what percent of data or what percent of the bars are going to be in between certain values of weight based on these benchmarks that we have right here. Okay, so based on these benchmarks. So the first one we're going to take a look at is what percent of data is going to be between 23 and 24.5 grams. Well, that's just between mu and mu plus 1 sigma. Okay, so that's just this one here. And so it's going to be quite simply 34%. Okay, that's all it is. It's 34% because it is right in between these two right here. Okay, we can solve that one quite quickly. 21.5 and 26 grams. 21.5 is right here. 26 is right there. That's going to be our 34 plus 34 plus 13.5. So again, all we're doing is we're just adding up the values here. 34% plus 34% plus 13.5%. And that's going to give us a total of 81.5%. Okay, so again, we're just adding up the sections. We're adding up the areas that are in between there. Okay. Between 20 and 23, well, that's here to here. Okay, that's the 34 plus 13.5. So we're going to put that in there. So it's going to be 34% plus 13.5%. And we get 47.5% in there. Okay, so again, we're adding up the sections in between. And greater than 27.5, well, that's just this little section up on top. Okay, it would just be that little part, which is just 0.05%. And so we're going to put that in 0.15%. Less than 24.5, well, that's right here. Less than would be on this side. Now, this all here is 50% up until the mean. Remember, less than the mean is 50, greater than the mean is 50. And so we're just going to add 34% onto 50. And so let's do that here. Less than 24.5 is going to be 50% plus 34%. So we just have 84% would be less than 24.5. So we're just adding up the sections which match the description. Okay, match the description. Now, question number 3 is asking, by how many standard deviations does a score of 26 differ from the mean? Well, the mean is here at 23 and 26 is up here, which is 2 standard deviations above. So it's just 2 standard deviations above which is the answer. So 26 grams is 2 standard deviations above the mean of 23 grams. Okay, so it's 2 standard deviations above. It's that gap. Okay, so again, each of these lines represents 1 standard deviation. And it's important to remember that it's 1 standard deviation each. Okay. So now let's look at some other ones here. So let's say that items that contain less than 21.5 grams will be rejected. How many are going to be rejected out of 2,000? Well, 21.5 is right here, so everything less is going to be rejected. Okay, this total here is 0.15 plus 2.35 plus 13.5, which means that it is a total of 16%. Okay, so 16% is in these 3 categories. So they're saying that 16% of their product will be rejected. Okay, 16% of the product will be rejected. Okay, I'm going to actually put that up there. And to find how many that is out of 2,000, we need to multiply 2,000 by 16%, which is 2,000 times 0.16. Remember, as a percentage, we just change it into a decimal, okay, divide it by 100. And so let's see here. Open up the calculator, which is going to take a little bit of time apparently. And we have 2,000 times 0.16, which would be 320 pieces of, or 320 candies. Sorry, chocolate bars. Let's get that right. Come on, this one. Okay. So it tells us how many will be rejected. Well, 320 of the 2,000 will be rejected. Okay. Now, in the same way, we can find if they make 25,000, how many will be rejected? Now, again, this is exactly what a lot of companies do. They're going to reject a certain percentage, and it's good to know how many that will be. Okay? Sometimes we want to make sure that we better our manufacturing based on that if too many are being rejected. So if they make 25,000, how many will be rejected? Well, we're going to do the same formula here, 25,000 times 0.16, and that will equal 25,000 times 0.16, 4,000 chocolate bars. So 4,000 chocolate bars will be rejected. And we can write that out in nice, neat order. 4,000 of the 25,000 will be rejected. Okay, so we find the percentage, we determine what percentage it's going to be, and then we multiply the percentage by the total to determine if it's what number is a part of it. Now, what is the probability that a measurement will be between 21.5 and 23 grams? Probability is just like percentage. 21.5 to 23 grams is 34%. So we can say, with some confidence at least, that 34% of the data is between 21.5 and 23 grams. Okay. So again, we can use those benchmarks, and it's important that we have those benchmarks and we use exactly those benchmarks. What is the probability that a measurement will be less than 20 grams? Well, 20 grams is right here. Less than is these 2 sections, which add up to 2.5 grams. Or sorry, 2.5%. So again, we can say that 2.5% of the data will be less than 20 grams. Okay, so 2.5% of the chocolate bars will be less than 20 grams. 34% of the chocolate bars will be between 21.5 and 23 grams.